Okay, so here's part two. We just kind of finished the basics. And so now what we're going to do is how do you find the inverse function of a given function? So that's what we're going to do here. So as we saw previously, the inverse function exchanges the x and y values of a given function. Similarly, we will switch the x and y variables of the given function and solve for y to find the inverse. Um, so here are kind of our steps for that. We're going to replace the function notation with y, and that's just kind of make life a little bit easier. Then we'll go ahead and interchange them. That's kind of our definition of inverses. They kind of switch roles. Um, we'll go ahead and solve for y, and once you solve for y, then we want to replace it with the inverse notation so we know that that's the inverse function. So we're going to start with a pretty easy one here. So we have f of x equals 2x minus 1. So we're going to change that to a y equals 2x minus 1. And then we're going to switch those. Okay. So now we're going to have x equals 2y minus 1. And now all we have to do is solve for y, and that is our inverse function. So we'll start by adding 1 to both sides of the equation. So on the left side, I'm going to have an x plus 1. And then on the right side, just a 2y now, because that will get canceled out. And then I really have only one more thing to do, and that will be to divide both sides by 2. So that'll cancel out. So I'm left with y equals x plus 1 divided by 2. And then we don't want to get mixed up, though. And so I'm going to label it as my inverse function using the proper notation. And there we go. That's the inverse function right there. And so once again, this is kind of one of those easy ones where you can kind of see like, oh, minus 1 plus 1 times 2 divide by 2. But moving forward, some of these won't be quite so obvious. All right, so let's see. Okay, so looking here at number 49, we have f of x equals 4 divided by x plus 7. So what we're going to do first, once again, is switch this over to a y equals, and we'll have 4 over x plus 7. Okay, so we are going to go ahead and swap our x and y. Now, this is kind of a technical thing, but I'll just go ahead and mention it real quick. X cannot equal -7. It's always kind of good to list any restricted values. So, anyways, that won't really play a role in our final answer for what we're going to have to do in these particular examples. But, okay, so we'll go ahead and do our little switch. So now we're going to have x equals 4 divided by y plus 7. Oh boy, how am I going to solve for y here? Well, let's see. Typically, to get rid of a fraction, I can multiply everything by the LCD, which in this case would be just a y plus 7. So I'm going to go ahead and multiply both sides by y plus 7. And what that will do for me is on the right side, that will cancel out. Come up here where I got room. And that will leave us with y plus 7 times x equals 4. Okay, so let's see. I got to solve for y. There's actually two different ways I could approach this. The first way would be to divide both sides by x, and so then I'd get y plus 7 equals 4 divided by x, and then I can subtract 7 from both sides, and that will cancel out the 7s, and I'll be left with y equals 4 divided by x minus 7. Nothing wrong with that. So let's see, that would be my inverse function right there. Okay, now I don't want to confuse you, but I do want to show you that what you could have done if you really wanted to. Over here, if I would have distributed the x, I would have had yx plus 7x equals 4. And it's going to look a little different, but the two answers will actually be equivalent. So I would have started by subtracting by 7x on both sides. And let's see, so that'd leave me with a y and x. Y times x equals 4 minus 7x. And then I would divide everything by x. And that would leave me with y equals 4 minus 7x over x. And it looks a little different, but they're actually equivalent answers. And when you're doing your homework, it would take it either way. Either answer would be correct. And so you could see if you were to divide both of these by x, you'd get 4 divided by x, and you'd get the x's would cancel out here, and you'd be left with a minus 7. But if you were to put either one of those in the computer or on an exam, that would be fine. Both of those are correct. So not trying to confuse you, but there are some equivalent forms here. All right. Okay, so let's go ahead and um, look at our next one here. Just real quick, another restricted value on the domain of my inverse function would be that x could not equal um, 0. So just pointing that out right there. Okay. All right. So let's go ahead. Here we go. So 51, it looks kind of similar, and it will actually kind of be a similar approach. So once again, we'll just go ahead and put y equals x plus 4 over x minus 3. And then you notice x appears twice, right? Well, once again, you do a switch. So the y becomes x, and any x will become y. So yes, I'll actually have y appearing twice. All right. And so, like I said, this is going to be kind of a similar approach to the last one. So we'll start by multiplying both sides by the LCD, which is going to be y minus 3. And so that will cancel with that. So now I'm left with y minus 3 times x equals y plus 4. Okay, a common thing that students will do, and it might be a little wishful thinking, they just want to subtract both sides by 4 and be done. And be like, okay, I get y equals, right? The problem with doing that is you can't have that y equals y minus 3 times x take away 4. You can't have your answer as part of what you're like trying to solve for. So I can't have y in my answer. So that's not going to work. Let's see. What do we typically do when we try to solve for a variable, right? What do we do? Well, we typically isolate it to one side, right? Well, in order to do this, what I'm going to do is I'm going to go ahead and distribute that x. In this particular example, I'm going to need to do that, okay? So I'm going to come up here and see what we have. So let's see, I'm going to have yx minus 3x equals y plus 4. Now remember, we're trying to solve for y, right? We're trying to solve for y. So I need to isolate the y's to one side and everything else to the other. And it doesn't matter which side. I typically like to keep whatever I'm solving for on the left side. It's you don't have to, but that's the way I like to do it. So what I'm going to do here is I'm going to subtract the y from both sides. Now, I don't have any, none of these are common, or none of these are like terms. Okay, this is x, y, this is x, and this is y, and this is a constant, 4. So none of them are like terms. So when I subtract a y from both sides, I can't like combine it with anything. So this has to stay y times x minus 3 times x. And I'm going to have to put a minus y right there, and then equals 4. I'm left with the 4 on the right side. And then let's see, anything that doesn't have the variable I'm looking for, I'm going to go ahead and remove it from that side. So I'm going to go ahead and add 3x here. So I need to add 3x over here. And so that'll cancel out with that. And now I'm going to be left with yx minus y equals 4 plus 3x. Okay, so I've isolated the variable I'm looking for to one side. That's good. And so I have to do something here, and it's something we've actually done a lot of. I'm gonna have to somehow turn two y's into a singular y. Like I said, y'all have done this a couple times. Let's see. We're gonna do your favorite thing. It's gonna be called factoring. Factoring. We're gonna go ahead and factor out a y. And so this is gonna give me y times x, and I have to put a -1 there, and then equals 4 plus 3x. So see, if I were to distribute the y, I'd go right back to what I have in my previous step. Don't want to do that. I want to go ahead and finish the problem. And so now that I have the singular y, I can go ahead and solve for it and isolate it by dividing both sides by x minus 1. And so we'll go ahead and do that. And so we're going to be left with y equals 4 plus 3x over x minus 1 right there. And that's going to be my inverse function. So my inverse function is 4 plus 3x divided by x minus 1. Now, I'm not going to show everything here, but if you were to isolate the y's to the right side of the equation, your answer would look a little like all the signs would actually be flipped. So it would be -4 minus 3x over -x plus 1. Once again, either one of those answers would be correct. They're just in different forms. So just kind of be aware of that if you were to isolate the y to the right side, the answer would come out looking different, but they would be equivalent. And one thing I kind of forgot to mention, once again, just kind of the excluded domain values. Like I said, it's not going to be a huge deal for what we're doing here. But if you go on to pre-calculus or something like that, you'll definitely take a little bit deeper look at the consequences of that. And so that would be the restricted value on the inverse domain. And then the restriction on the original function domain would be +3. So just going to mention that. Okay, I got a couple more, but this is the good news. That this is the most difficult one we're going to see in this video, okay? So it's a little bit easier on our last couple. All right, so looking at this, I don't see any restrictions to the domain, so we're good to go. So let's see, we're going to do y equals, let's see, we're going to have x cubed minus 1. So now we'll do the switch. So we're going to have x equals y to the power of 3 minus 1. Now it's time to solve for y. So we're going to add 1 to both sides to get started. And I'm going to come up here. So see, I'm going to put y cubed on the left, and then I'm going to have x plus 1 on the other side. So I just flip-flop the two sides. And then what's the inverse operation of a cube power? A cube root. A cube root would be the inverse operation. So that will nullify the cube power, and we're going to be left with y equals the cube root of x plus 1. And so that's what my inverse function is going to be. There we go. Okay, so our next example, we kind of get a little bit into the weeds when it comes to the domain issue that I've been hinting at. So the issue with number 57 is without this restriction on the domain, we would not have a one-to-one function and we'd have an issue. So the shape of this graph is a parabola, but the problem is that's not one-to-one. But what we do here is we restrict the domain to only x values greater than 0. So that's going to cut that into this. It's just half of a parabola. And now it is one-to-one, and we can go ahead and find the inverse function. Okay, So let's see, we're going to start out with changing it to y equals 5x squared minus 2. Then we're going to switch the y to an x, and then the x to a y. Everything else stays where it's at, including the power. So don't move the power, okay? All right. And so then we are going to add 2 to both sides. I'll cancel out that. And I'm going to kind of bring this over here. I'm going to put my 5y squared here. And then I'm going to have an x plus 2 on the other side. Then we are going to divide by 5 on both sides. So now we have y squared equals x plus 2 divided by 5. And then to nullify the square power, we're going to have to square root. But it's going to be a little different from when we cube rooted. If you do an even root to both sides, you have to put a plus or minus on the other side right there for the part that we're simplifying on the right. So the square root will nullify the square power right there. So we're going to be left with y equals, now, right now it's a plus or minus, but we're going to have to figure out, is it positive or negative? Because it's going to be impossible for us to actually use both of those, because that would mean that the inverse function is not 1-to-1. Because when I plug in an x, when I have a y value, I could have 2 different x values in return, and that would be a problem. So this is where the kind of the domain stuff kind of comes into play here. So if you look right here, my domain on the original function was that all my x values needed to be greater than or equal to 0. So that was the domain. Now remember what happens. When I go to my inverse function, domain and range switch. So that means now that my range is going to have to be from 0 to infinity. So I can't get any negative y values. I can't get any negative range values. So that means that we're going to go ahead and only look at this in terms of being positive, because I can't look at it as being negative because it's restricted. You can tell from the very beginning, my domain could only be positive values. So my range can only be positive values on my answer. So my inverse function, and by the way, we're not going to worry about rationalizing this. On your homework, you don't have to rationalize it. And so I'm not really going to take the time to go through that right now. So that answer is fine. You can put that answer in on your homework, and that shouldn't be an issue. And same thing with the exam. I won't, I'm not going to force you to rationalize that. Typically, we always like to rationalize, but this kind of gets a little messy, and I just rather not really deal with that right now. Okay, last one, and this one's actually fairly simple. It's actually going to be the opposite of the previous one we just got done doing. So see, look at my answer here. That kind of looks like the problem. So we're just going to kind of go in reverse here. Okay. Oh dear. By the way, on my domain on number 60, there are no restricted values, because when you cube root, it's okay to cube root positive and negative numbers, so that doesn't really cause an issue. Okay, so we'll follow our directions. So y equals the cube root of x minus 8. Then we're going to replace y with x and x with y. And then we got to go ahead and solve for y. Well, currently my y value is trapped under a cube root. Okay, so the inverse of the cube root would be to raise to a power of 3. And so that's what we'll do here. So now we're going to have x cubed equals y minus 8, because that goes away. And then the last thing we're going to do here is we're going to go ahead and add 8 to both sides. And so we're going to be left with y equals x to the power of 3 plus 8. And there we go. That's it. So my inverse function is x to the power of 3 plus 8. All right.